when reading gas law problems, I usually will highlight the values for pressure, temperature, and volume that the problem will be giving me, because I'm going to need them when I use the combined gas law coming up. Okay, but first let's annotate and see what we find. A light bulb contains argon gas at a temperature of 295 K, that's kelvins. So they gave me one temperature right here, and that's the original temperature. So I'm going to actually annotate that a little bit further and say that that is the temperature, right, which is T, but it's the original one, which means that it's T1, right? And then I'm going to continue reading. And a pressure of 75 kPa, kilopascals. Okay, so they even told me that that's a pressure. So I'm going to state that that is P, but it's the P that is the original one. So it's P1, right? Okay, so let's continue. The light bulb is switched on, and after 30 minutes, its temperature is 418. Well, that makes sense. You know how light bulbs get hotter as they're on for a while. So this one went from 295 degrees, kelvins, all the way up to 418 kelvins. So this right here is definitely a temperature, but it's the final temperature after the change. After the light bulb was on for those 30 minutes, this is actually T2, right? The second condition of it, right? Originally it was 295 and then it was 418. That's where the 1 and the 2 come in. All right, what else do we know? Calculate the pressure. So this is what we don't know, and we need to find pressure of the gas. So I need to find pressure P2, right? Like the final pressure. P2, I don't know it. Of the gas inside the light bulb. Assume the volume remains constant. Now here is something that you're going to be very happy about, okay? Anytime that you see that any of these variables are constant, right, that you can actually get from the problem that that particular variable didn't change, they kept it locked. What we are going to go with is that we're going to eliminate that variable from our formula. So basically the volume doesn't really matter, so I'm going to kind of get rid of it. And in my listing here, I'm just going to jot down what I have and completely ignore the volume because it remains constant. So then that means no change is going to come and be an effect in our gas. Yeah. Now, pressure 1, I found it right here, right? So that is 75 kilopascals. Pressure 2 is what I don't know, so this is my question mark. Temperature 1 was 295, and at the end it was 418. So now that I've done that and I've taken all my values out, I'm able to go ahead and actually solve the problem, okay, by substituting on the formula. Again, it is P1 V1 over T equals P2 V2 over T2. All right, I'm going to substitute. Now remember, I just remember something that I was very happy about. Remember how volume was not needed? So then I can actually get rid of them in the formula. And what was a 6-variable equation all of a sudden became a 4-variable equation. And that looks way, way nicer, right? So P1 was 75. T1 was 295. So I'm just substituting. P2 is what I don't know. So I'm just going to keep it as a variable. You can put X, but I like to keep P2 so that I know what I'm looking for. And T2, right, is going to be the 418. So I basically just taking these numbers that we just found and substituted where they belonged in the formula. So now that we're here, what do we do? Anybody remembers cross multiplying? Or actually, I think what you typically do is that you do the opposite operation, right? So you're going to take on both sides and try to leave the pressure variable alone. You're going to multiply on both sides by 418, which is actually the same as saying that you're going to multiply 295 times P, and that's going to be equal to 75 times 418, and I'm going to just write that down. Times 418 is equal to 295 times P2. That is called cross multiplying. I'm going to take those two sides diagonally and make them equal to each other. Then I would just go ahead and do whatever it takes to get rid of the 295, which is the opposite operation, is going to be dividing because it's being multiplied right now. I'm going to be able to cancel that out and then define that P2 is actually going to be this calculation right here of 75 times 418 divided by 295, and that is going to result in 106.27. So I'm going to say 106.3, and it's in kilopascals because my first measurement was also in kilopascals, so I'm going to keep it the same. And this is the answer to this question.